Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 3D programming. This is a boot camp. The goal of today's webinar is to get more out of your CAM software by learning to use common 3D toolpaths and options. As you know, my name is Al DiPaolo. I'm the voice of the Bobcat After Dark video series. You can find me on Instagram at BobCAD-CAM, or you can also follow hashtag BobCAD or hashtag BobCAM. All right, so today we're going to look at this valve cover. This is the same part we had done last year in our 3D boot camp. It's updated slightly with a little difference of geometry. There's a lot to cover. This is a 5-part webinar series, so that way we can really dig in and get into this some more. We're going to learn about Z-level roughing. We're going to learn about Z-level finish and also planar. These are the most common 3-axis toolpaths you'll use. We'll talk about a variety of different settings so you can really get familiar with them and know when and where and why to use them. Okay. Now, as always with BobCAD, you can expect fewer steps, better cuts, and more profit. So give me just a moment here while I get my screen set up and we'll get started in today's webinar. Okay, here's the part that we worked on last year. Again, we have our Z-level rough to rough the majority of the material out. Z-level rough is like a 3D pocket. We have Z-level finish. That's to machine the more steep areas of the part. That's kind of like a 3D profile. And then you have planar, also known as parallel, which will move back and forth over the part. And this we'll use to machine the more shallow areas of the part. Okay, so these are your 3 most common strategies. These are the ones that we want to take a look at. There's a couple of topics that I want to cover real quick before we get too far into this. Number 1, how do you toggle your shading on and off? So right now you have your surfaces and they're being rendered. If you hit S on your keyboard, you can toggle the shading. If you hit W, you can toggle the UV lines. If you hit T for transparent, you can toggle transparency, okay? Where are all the hotkeys at? There are a lot of hotkeys that make using the software faster. If you go under preferences and then shortcuts, this is where all the hotkeys are located. You can see which ones are set up, and you can also use your own. Why do you use planar? Planar is a very good catch-all toolpath. There's a number of reasons why we use this. Planar, again, is very popular, and this one's going to move back and forth over your model to machine the surfaces that you've selected, okay? So planar is just a really good strategy to machine shallow areas of your parts, and again, you're going to find it very common. How do you set up speeds and feeds for other materials? There is a material database. Mine actually is not on this particular computer, but you can add a new group. You can give it a name. You can add a material, and then from here you can give the material a name, and you can edit the surface footage and the chip load for each of the different areas, like the different types of tools. So it's really easy to set up, but usually I just default the speed and feed for a cutter. Where can you save a feature? These are our features. Features are basically groups of toolpaths that can be applied to an geometry set. So that's the geometry set. Z-level rough is the toolpath, and the feature is what contains that toolpath. Okay, you can take these features and right-click and choose Save Feature. That way you can save it out to a directory and reload the tool and depth of cut and other settings of that feature. So you can save these out locally to your computer. The other thing you can do with these features is you can copy and you can paste them within the setup or within multiple setups, okay? So how do you control the machining order? So we have different machining operations here. We're using different tools. If we go up to the top here where it says machining order, this will list out all of our features, and then we can choose how we're going to post out, whether it's feature dominant, whether it's tool dominant, across the setup or across all setups. And then you can reorganize these as well just by moving them up or down in the machining order dialog. Okay. There's another question here. What do you do to set your rapid plane move between operations? When the tool is going to go to clearance between operations, you're going to find under machine setup, there is a clearance plane. That is the position the tool will go to between features or between operations. Okay. All right, let's see what else we have here. Why do you use pocket in or out? When we're doing our Z-level rough here, when we get into this pattern here, you have pocket in or pocket out. This is just going to determine the direction of the tool path, whether it works from the outside in or whether it works from the inside out. How do boundaries affect your tool path? Boundaries are going to be used to limit where the tool path is being created. Let me see here. In this example, if I remove my boundary and I recompute the toolpath, you're going to see the toolpath is going to go out to the stock geometry. In this case, this is my stock. It's ghosted, but you can see that's the stock geometry. So I'm using this boundary. By selecting this boundary, I'm containing the toolpath. So instead of it going out to the stock, now what it's going to do is get contained by that toolpath. So that's another very important feature there. So these are just some of the question and answers that we had from last year's, the 2017 boot camp. So I just wanted to start with those real quick. Now, a lot of times you'll see images of work holding and setup, so I want to address how that's handled, and then I also want to start this project from scratch and go through some of the setup here. So give me just a second while I open a new file. Okay, so here we have some vices. There, I have two of them back to back. You can download these work holding models from any major work holding provider, whether it's Kurt or whoever it is that you may subscribe to. They'll generally have models that you can download, and that's what I've done here is I went online and I downloaded this. I have put two models together, or two vices, because that is what's appropriate for this particular example. Now, one of the things that I do recommend, if you notice on the jaws here, all the threads have been modeled into this part. I do recommend you consider simplifying your geometry. You may not even need the bases. You may just use the jaws themselves because it accomplishes the same result. But if you simplify that geometry, it's going to be very useful. Now, one of the other things to consider is when you're trying to set up these models, you're going to need to move the jaws in or out to adjust. So you can use translate on something like this. You can grab some of your components here, and then you can drag these in or out as necessary to move the jaws in to align with your work holding. Okay, I recommend that you import and set up these models, whether it's a single vise or multiple vices, and you save it in a work holding directory. And then that way you can use it on future projects. So we're going to take a look at that here today. So let me give me just a second while I set up my next screen. Okay, so here's my part model. I actually modeled this in SolidWorks and then brought it in as an SLD PRT file. There are some things that I noticed with the file right away that are a little strange, and this does happen from time to time, so just to be aware of it. But you know, just kind of the way that it feels when it's rotating, it just doesn't feel right. If I do a fit all, you'll notice that it kind of doesn't really center the part model as well. So this is an indication that there may be something going on with this model. Okay, so how I'm gonna remedy this is one of the things that I could do is I could go back into SolidWorks and make changes or adjustments and kind of see what's going on. But if you don't have the original file, you may need to make some adjustments yourself. So in this example here, one of the things that I'm going to do is I'm going to unstitch the model, and it's going to break it down to individual surfaces. And when I do that, I get an error that comes up and it says at least one surface could not be successfully unstitched. Okay, when I do that, the surfaces that we have problems with actually are dropped. So you can see there's some surfaces here that were dropped, and there's some surfaces here that are dropped. Now, a dropped surface isn't the end of the world. It does take a little repair to go in there and clean it up. How I would do that is I would create a layer, and then I'm going to come in and extract the wireframe for the neighboring surfaces, okay? So I could either pick just the edges or I could pick the faces, but this is essentially the gap that I want to fill. So I'm grabbing the edges for that, and then I'm going to say okay, and then I can minimize, or I'm sorry, blank that the model itself. I can work just with this wireframe here, and then I can come in and repair that or build in another surface. And that's what I'm going to do here. I'm just going to create another layer so I have some separation. I'll do surface, skin. I'm going to select these two going in this direction. I'm going to select these two going in this direction. I'll get a preview, and there you can see I've now filled that surface. Okay, I'm gonna have to repeat this process 3 more times because there's another drop surface on this area. So I'll do it again. It's really not, in this case, it's very straightforward. So again, we're gonna go extract edges. We're gonna click on the neighboring edges of where the surface was dropped. We'll go ahead and create the wireframe for it. From here, now that we have that wireframe, we can come in and do our skin for it. So we'll do a skin. We're going to go this way and this way. And there are some keystrokes that I'm doing here in order to get this to come out the way that I want. So we have these two surfaces. We'll bring our model back up, and we'll notice that there is another gap on this side over here. So we're going to just repeat the process. So we go over to the area, we're going to add a new layer. We'll do extract edges single, and then we're going to just click on the edges that encompass where we need to fill in this surface. So we'll do that area there. We'll blank it out. We'll do another skin here. Now, so just to kind of slow down a little bit here, I pay attention to the midpoint of the entity being the line or arc, because that's going to tell me which way the arrow is going to go. So I'm going to left click on this side. Because I'm done, I only need to select one entity. I'm going to shift left click, and then that gives me the start arrow and then the end arrow. Same thing here, click on this side, shift left click, that gives me my 2 cross sections. Then I'm going to grab my rails. There is a certain order that you do this in, but when you've done 2 or 3 of them, it really it speeds up pretty quickly for you. All right, so we're going to turn this over. Again, we're going to repair this area as well. So we're going to do extract edges single. We'll come in and grab all the neighboring faces. We get our wireframe. We'll turn our model off. Surface, skin, left click, shift left click, left click, shift left click. We go to the rail curves, left click, shift left click, left click, shift left click, space bar, cancel. All right. So that was all the steps that it took to repair the surfaces there. You can see in our tree, we unstitched and then we added these skins to fill those gaps. All right. So now what I'm going to do is I'm going to go to stitching, stitch surface to solid, select all, space bar, and then what that's going to do is make this back into a single object. Okay. All right. So now we have our one solid here. Okay. So the next thing that we want to do is get our work holding into the part. Now, what I'm going to do is I'm going to create a new file, and I'm going to do file merge, and then that will let me merge. It's kind of like opening a file, but I can merge the work holding into a part. So like if I go back to this part here, I can do file merge. But before I do that, because this is a SolidWorks file, what I'm going to want to do is save the file as a BBCD file. And then once I've done that, then I'll do the merge. So give me just a second while I save this file. Okay, so I've just saved it as I'm saving it as a BBCD file. What I want to do from here is I want to do file merge, and then I'm going to go to my work holding, and I'm going to grab my 2 up, and I'll say okay. Now what this will do is merge those models into this part file. Once they're done opening up, what we're going to see is, I believe they're going to be on the CAD layer. So if we make the CAD layer visible, we can see these, the work holding is now added to our part file. Okay. So if I go to a right view here, so if I go to a right view, you can see the spacing for this, you know, to get this on this face here or mated with that face, there's some measurements that we need to do. So what we're going to do is just go to measure 2, and then we can click on this one here, and we'll grab this edge, and then we can click on that one there, and we'll grab that edge. And then what that's going to do is kind of figure it out for us. The value that we want here is the Z value, so we can actually just take this value and copy and then cancel, and we'll go to a right view. All right, so now what I'm going to do is move all the work holding up. So we'll do a translate. We can window pick our model here, space bar to lock it in, and then I'm just going to add that value that I copied and pasted, and we'll say OK to move everything up. Once it moves into position, then we can cancel out of the feature and call it a day. All right, so that is just a quick example of how to utilize your work holding. Again, if I needed to move the jaws in or out, let me go to a right view here. If I needed to move the jaws in or out, I could do a utilities translate, select the bodies that I want to move, you know, and then you can either enter a value here, or what we could do is drag along with this handle. So we can move it in or out by entering a value, or we can drag our handle down the line. The one thing that you have to watch out is sometimes when you drag this handle, it picks up some of the other values, the X and Y. So you want to make sure you zero that out before you lock it in. Okay. So that is a quick example of getting our work holding there. Okay. So now there is, what I want to do is a little bit of cleanup here. So we'll say work holding, and then I'm going to go and take all of the models for the work holding. I'm just going to select them and put them on their own layer, and then I can hide that layer. Okay, so I have my part geometry here. What I'll do is create another layer. We'll call this model. We'll make it active, select all our geometry, and move it over to that layer. Okay, so now what we have here is we have our model, and then we have our work holding. Okay. All right. We'll go back to a top view. And so when we go to set up our job here, there is another measurement that I'm going to need. I'm going to need from the top of the part down to the bottom of the vise, so I know what that value is. Okay. And I'll show you why in just a second. Let me hide the work holding. Let's go ahead and create a new milling job. Okay. In this job, we're going to just use the rectangular stock. It will look at the part geometry and find the minimum maximum. We can add additional stock in X, Y, or Z as needed. In our example here, I'm just going to leave it where it's at. I'm going to choose next. I'm going to want to pick my origin, which let me go back and move forward. Okay. I want to grab top center in this example, and I'm going to say OK. One of the things that is very useful is that bounding box that we saw that came up when we were going to set our 0. So if we go back and we go to edit our machine setup, the bounding box will come up with all these point locations. So what I'm going to do is create a new layer, and if I just click measure, what it will do is actually move all that geometry over to this layer here. So that way I have those reference points that I can use later in the project if I need to. Okay. In this case, I do need to, because I need to find the distance from the bottom of the vise to the top of the material. And I'm going to measure these values here. So I'll just use a snap point there and a snap point here, and this will give me the value that I'm looking for, this Z value right here. So what I'm going to do is copy that value. Once I have that copied, I'm going to use that. Now where I use that is actually in the machine setup here. There's a work offset. The reason why I use this is because I have machine simulation, and this Z value is going to tell the machine simulation how far to move the vise and the workpiece and everything up off the table. Okay, because the 0 for the job of the machine is the top of the table. So this allows me to move my all my work up, just like a work offset works on a real machine. Okay, so we have all that set up. Let's go ahead and turn off our work holding. Again, this is a boot camp for 3D machining, so there's a lot of topics that we're going to talk about. Because there's so many topics, instead of just kind of brushing through them, I'm going to spend a little more time each week with one of the tool paths and really kind of dial in. So this first round is really just importing the model and using the work holding. Now, some of you may want to work along with this tutorial. I do have all of the vices and the SolidWorks model on GrabCAD, so you can download it and work along with it, okay? So that's available for you. I was going to bring like a tool crib in there as well, but that I think was a little too far for this example.